Good morning, good afternoon, and good evening to everyone joining us from different parts of the world. A very warm welcome to day 3 of the 5th International Conference on Universal Threats in Expert Applications and Solutions, or as we fondly call it, UNI-TEAS 2026. I am Shambhavi Tomar, and it's an absolute pleasure to moderate today's online session. This prestigious conference is being organized by Shree KKarni Universe College, Apex University, and Panipat Institute of Engineering and Technology, managed by KK Consultancy Services India and supported by University of Rajasthan, ACM Jaipur Chapter, All India Council for Technical Education, and Computer Society of India Jaipur Chapter. This year, we received an overwhelming response with over 300 paper submissions from across the globe. After filtering out AI generated and plagiarized content and a rigorous peer review process by our expert panel, only the top 80 papers were selected for presentation. Based on their performance and the recommendations of our session chairs, these selected papers will be published by Springer Nature. The first half of the day 1, that is 16th of February 2026, we had an incredible series of keynotes, paper presentations, award ceremony, and discussions that truly embodied the spirit of innovation and inclusivity offline in Jaipur. As we step into the latter half of the day 3, we carry forward that same enthusiasm, ready to dive deeper into thought provoking sessions and interactive presentations that will continue to shape the future of intelligent systems and digital security. With that, I am pleased to introduce our session chair for this segment. We have Vishal Bharti sir, who is the principal and professor at Maharishi Markandeshwar, deemed to the university at Mullana, Haryana. Before we proceed further, I would like to share a few important instructions for all the paper presenters to ensure a smooth and timely session. First, each presenter has 10 minutes to present. Please stay within the time limit. Second, briefly cover your research context, objectives, methodology, key findings, and conclusion. Third, a short Q&A may follow your talk of 1 to 2 minutes. Keep your responses brief and focused. Fourth, keep your mic muted when not speaking. And fifth, stay for the full session to support the fellow presenters. With the kind permission of our session chair, we shall now proceed with the paper presentations. Sir, maybe?
Yes, please go ahead.
Okay. So I would like to invite our first presenter for the day, who is going to present the paper titled LLMs as Behavioral Test Beds, Replicating Economic Regularities via Prompted Agent Setups under the paper ID 395 by Ranjit Patnaik Sekhar Mantri. Do we have him or any of his fellow paper presenters? Okay. So let's take up the next paper by Rohit Prajapati and Hiren Joshi under the title Feature Selection Techniques for Resource Estimation on the Cloud Workload under the paper ID 308. Okay. Okay, so let's take up the paper presentation of Soumya Singh under the title Analyzing the Impact of Different Data Pre-Processing Techniques on Network Intrusion Detection Performance under the paper ID 574. You may take the virtual stage and begin with your presentation.
Good evening, everyone. Myself Soumya, and I'll be representing my research on analyzing the impact of different data reprocessing technique on network intrusion detection system. So, ma'am, may I represent, can I share the screen?
Yes, yes.
Okay, thank you, ma'am. I'll be sharing my screen. Ma'am, is it visible? Hello.
Yes, it's visible.
Okay, ma'am. So, so as you know, the growth of network systems are very high, and with that, the risk of cybercrime and cyber attacks are very well known, and the traditional security systems are insufficient. Mm. So that's why we need IDS, Network Intrusion Detection System, which play a crucial role in learning the unseen patterns of attacks. So the problem statement is like the network dataset contains noise, missing values, and imbalanced classes. So the models that we will train on raw data may perform poorly because as they had noise and missing values. So that's where pre-processing comes in the picture, and for that pre-processing is often treated as secondary, not as primarily. So what the objective of our study is, like we compare the models trained on raw data and pre-processed data, as you can see in the picture, and we have used the same dataset and same bits, and we ensured that fairness by using the same dataset, and we evaluated performance using accuracy, precision, recall, and F1 score that we'll be taking on next upcoming slides. So there are very various related work. So many papers use techniques like naive Bayes, decision tree, and random forest. TCA and dimension reduction explored in past studies also. Pre-processing shown to improve accuracy, but rarely isolated for the study. And our existing work emphasizes on algorithm comparison. As we all know that pre-processing is treated as minor step, not analyzed deeply. The overlooked execution time, like execution time is like the attack is in how much time the attack is known, and scalability like the attack is very high scale or not, and performance trade-offs like if accuracy is higher, so it may be not good for the models. So the dataset which we have used is NSL-KDD dataset. It has 41 features, numeric plus categorical. Attack categories like denial of services, probe, R2L, remote to local users, and U2R, user to remote, are there in this dataset. And the challenges is class imbalance. Like class imbalance means suppose there are attacks of DOS, probe, and R2L and U2R, but out of thousands of normal traffic, 900 is normal traffic, and the various are DOS, probe, R2L, and U2R. So the accuracy that will show, it will show that like 90% the traffic is normal and rare attacks are underrepresented. And we have tested ideal for testing preprocessing, normalization, encoding, and balancing. So here comes the important part, preprocessing framework. So we have designed a structured pipeline. First, raw data handling. This is baseline performance. Like first, we train model directly on raw data without applying preprocessing. So this helps us to create a baseline for comparison. And then data cleaning, and we remove duplicate records and handled inconsistencies. And we also reduce noise in the dataset. Next is feature encoding. One hot coding for categorical features. Some features like protocol type and service categoricals. Since machine learning models understand only numbers, so we converted them using one hot coding. And then comes normalization. Mm, Network features have different values. For example, I can say byte count can be very large while duration is small. Normalization scales all features to a common range. Then feature selections. Uh, we reduce irrelevant attributes and features. So by this, we can reduce complexity and improve model stability. We have used classifiers like nav bias. Uh, it represent probability. It is fast and efficient. It performs poorly on raw noisy data, and it is strongly benefited from normalization and encoding. Decision tree handles non-linear patterns. It is sensitive to noise. Random forest. It is assemble and robust to imbalance. Rational covers probability, logic, and assemble that we have covered. Evaluation metrics. We have used four evaluation metrics. Accuracy means overall correctness predictions. Suppose if 80% of data is normal, so the model can predict normal always, still it get 80% accuracy. So that's not good. And precision, it correctly detects attacks. Like if low precision is there, too many false alarm will be there. And recall, ability to catch actual threat. If there is slow recall, missed attacks will be there. And missed attacks can system get hacks. And now F1 scores. It balance between precision and recall. As we can see the results, proposing improved performance across all models, like you can see here. And random forest achieved the highest accuracy at 86.7%. Naive bias shows the highest relative improvement. Here is the F1 graph, performance analysis graph. F1 scored improve all models, pre-processing enhanced precision recall balance, and random forest achieved highest F1 in 0.86. This is improvement summary table. Naive bias is plus 6.3, decision tree is plus 5.0, and random forest is plus 5.4. And this is a discussion part. Pre-processing is crucial for IDS effectiveness, as we have talked about. Nav wires gain most from normalization and encoding. Decision tree improved by noise reduction as it reduces noise and class imbalances. Random forest is strongest overall. Conclusion: pre-processing significantly boosts IDS performance, improves accuracy, precision, recall, and FN score. Reliable detection of unseen threats. Key takeaways are like data quality is as important as algorithm choice. Thank you.
Thank you so much for your insightful presentation.
Thank you,
We
ma'am.
take up, we may take up any questions from the session chair or the audience. Also, I would like to introduce our session chair, Surendra Yadav sir, who is the dean at Vivekananda Global University, Jaipur.
Thank you, ma'am.
Thank you, sir.
Okay, ma'am. No question, ma'am.
Okay, okay. Okay, so now we may move on to the next presenter. Uh, can can Ronak Goda please tell me the paper title and ID of his paper?
My name is Ronak Guda, and I would like
Yes,
to
sir.
inform that Vijay sir has given me permission to present my topic, as my
Hmm.
was not included in the list earlier. So he suggests
Okay.
I can give my presentation during the last 4 sessions. So I kindly
Okay,
request
so
me permissions as well as
yes, so what is the title of your paper and ID?
so that I will share my screen.
Okay, so you may start presenting.
Okay. Can you see this screen, ma'am?
Yes, start.
Yes, but
Okay.
can you please tell me the paper ID?
637.
Okay, okay, thank you. You may begin.
Okay. Thank you, ma'am. Thank you, sir. So my topic is a hybrid deep learning framework for the continuous and isolated sign language to text translation using a 3D CNN. So some my index contents, introductions, problem statements, objectives, continuous isolation sign language, propose a hybrid framework, design and explain details, result and discussion, conclusion and references. So first of all, introductions, sign language is a non-verbal with the speech, hearing the intent to convey the feelings and ideas to others. So like the sign language is the visual language used by the millions of the hearing impaired individual worldwide. So communication between the sign language users and the non-signs remains a major barriers in the society. So some effective communication is crucial for the sharing source ideas. So sign language is used by the between around 5 lakhs to 20 lakhs hearing the impaired the individual state. So recent advances in the deep learning, especially video-based models, having a significant improve and recognize accuracy. Okay, so next one is the problem statement. So there are some problems. Automatically, sign language to text translation is challenging due to complex hand gestures, facial expressions, motions, variations like that. So continuous signs lacks a clear and word boundaries and making a segmentations and recognizing difficulties. So continuous signs does not contains clear the pause between the words, making a segmentations difficulty. So therefore, the effective spatial deep learning model is required. So there's some main objectives here. So design and intelligent systems that recognize the both isolated and continuous sign languages gestures. So second one is to extract the meaningful emotions features from the sign videos using a 3D CNN. To translate the continuous sign sequence into grammatically correct text statements. So you will use the systems using a standard recognize and translations matrix. There are some fourth objectives in my topic. So some differences between the continuous and isolated sign language recognizing systems. So first is the isolated sign recognizing. So it's isolation recognizes each is signs performed independently one at a time. So the systems are classified the single gestures. So like hello, thank you, waters, bye, whatever. So since our signs have a clear start and end the boundaries, so recognizing becomes easier. So next one is a continuous sign recognizing. So continuous sign recognizes deals with the completely sentence. So where the multiple signs are performed in the same sequence, so like I want to water, my name is Rona, whatever. So there are the no clear pause between the gestures and making it difficult to identify word boundaries is continuously. So work is continuously. So these are the some difference between the continuous and isolated. So these are the some my algorithm charts. Is isolated and thereafter continuous sign language. So propose a hybrid frameworks. These are the some details that the proposed systems design for the both isolated and continuous sign language translations. So they are the three purposes: 3D conversations neural network, 3D CNN, sequential model modeling, and text decoders. So what is the role of the 3D CNN? So 2D CNN's models extract the spatial feature from the single image, but however, the sign language is dynamically and they depend on the motion across the frames. So why choose 3D CNN? So 3D CNN some advantages here. So height, width, times. So thereafter learns motions patterns such as hand movements, direction, and speed. Sorry. So provide a richer functional representation, making it suitable for the gestures-based video recognizing. Sorry for that. So some my systems architectures workflow. So first is input videos, pre-processing stage like frames extractions, resizing and normalizations, noise reductions, feature extraction using a 3D CNN, sequential learning modules, and output text generations. So like that, some my practically working that pictures. So isolated signs and continuous signs video. So like working the hello words and in the morning in the morning. So these are the some preparations. Pre-processing techniques are frame standardization for uniform input size, data aggregations like rotations or flipping, sequential padding to handle variable length videos, and these steps improve the robustness and reducing overfittings. So some my results analysis and performance. So these are the continuous science metrics and values. Sentence accuracy is around that 90 percentage. WR's word error rate 12.8 and the blue scores 0.84. And the isolated is compared to these scenarios. Accuracy is a 95.2, precision is a 94.8 around the 95s, and recalls the 95 around that. So these are the indicators from the classification and capability for the individual sciences. So some conclusions here. The purpose the 3D CNN based on the framework successfully handles so both isolated and continuous sign languages. So uh, some features the scope is the training on the larger real world data sets, real time implementation for the particular uses, integration with the speech synthetic for the complete the accessibility tools. So they are the develop the tools and multilingual the sign language translation supports. This is my dream and just here I just found out some references that here. Thank you, sir. Thank you, ma'am.
Thank you so much for your well articulated presentation. Now, I would like to invite our next presenter, Ranjit Patnaik Shekhar Mantri, who is going to present his paper titled LLMs as Behavioral Test Beds Replicating Economic Regularities via Prompted Agent Setups under the paper ID 395. Over to you.
Sure. So can you give me just 5 minutes? I just joined, so I'm just opening my file.
Okay. I would like to confirm what was the paper ID of Ronak Koda. It was 637, right?
Yes, ma'am.
Okay.
Because I
We can
generate
take.
the new paper ID.
Oh, okay. We can take up any questions from his presentation, from the session chair, or from the audience, if any.
No, madam.
Okay, sir.
Hi. So is my screen visible?
Yes, it is visible.
So today I would like to present for LLMs as a behavior test beds replicating economic regularities. So hello everyone. My name is Ranjit Patnaik Shekhar Mantri. So the main idea is simple. Like instead of using large language models only for the test generation, we can use them as a configurable test subjects almost like a simulated participant to study economic decision makings. Like significantly, I'm asking like if we give an LLM clear identity, goal, and the context true, controlled prompting can it reproduce the same kinds of behavioral patterns we repeatedly observe in human economic environments. And If it can, then the LLMs become more powerful and persisting tool for the researchers, helping us explore ideas quickly. We invest in the real human studies. So traditionally, economics and relied heavily. So traditionally, economics relied heavily on the rational agent. Sorry, just a second. Sorry, I'm having a trouble. Please give me 1 second.
Ma'am, any other? This is last one?
Yes, sir. So far, it is the last one. Two of the presenters have not come.
ठीक. Okay, ma'am.
I'm sorry. So shall we continue?
Yes, please. You only had 10 minutes, so please be quick.
Sure. So behavior economics challenge that showing human Homo sapiens are not perfectly rational. So we have systematic basis. We care about the fairness. We dislike losses and we stick to defaults. And we make decisions based on the framing. So now we have the third candidate emerging. Homocelious AI agents, especially LLMs acting in the decision environments. So the shift here is we are evolving from theorizing about the behavior to simulating behavior. The key is whether these AI agents can actually replacement patterns like fairness, preference, or the status. And why the LLMs work as economic agents. So LLMs are trained on the huge amount of LLMs are trained as a huge amount of language books, articles, and the conversations. The training implicitly includes human social norms and the moral reasoning and common judgment what is fair or unfair. And the second reason is practical. This approach is cost effective and reproducible. Instead of recruiting participants, we can run hundreds of simulations and systematically vary parameters like persona or goal and get structured outputs quickly. And when it comes to simulation architecture framework, we start with behavioral scenario. This is the economic decision context expressed in natural language. For the example, allocating money between two people and judging if a price increase is fair or deciding between job candidates. Then we add experimental variables. This is critical. So we configure the agent with the endowment such as a persona, a bias, and a goal or a constraint. And finally, we collect the decision output. The output can be uh, a critical choice like option A or option B, and a quantitative rating like fairness scores. And the four key behavior experiments is like I ran four classical behavioral experiment families across a total of 630 simulations. The first category is preferences like social preference trade-off and fairness versus efficiency. And the second category is market fairness, whether a price increase after a shock is judged or acceptable. Then bias, like status through the bias through default influence what the people choose. And the finally is labor substitution, a hiring decision under wage constraints inspired by a minimum wage effects. So the goal is not just the model answer something. So the goal is I change the framing or the persona. Does the model shift in the same direction what human shift in the experiments? Strong similarities to the human behavior, like across all experiments, the similarity indices fall between 0.92 and 0.96. The overall correlation with human benchmarks is strong or equals to 0.91. What that means in plain language is when we look at the distribution of choices the LLM makes, we compare it with the human typically do these in the classical experiments. The alignment is perfect, but the
Mr. Ranjit,
constraint.
what
Yeah.
is your result and what is your conclusion?
Um, okay.
What is your conclusion?
Like AI human collaboration framework, like the idea of homogeneous is not AI replace Homo sapiens. Instead, that AI is accelerated tool and the compilation partner that helps researchers bridge theory and empirical work. Instead, it's AI as a acceleration tool, and so rather than jumping into straight from economical theory to expensive human trials, we insert a middle layer. This creates a new experimental like faster exploration and scalable testing and reproducible setups. And finally, for the future directions, first expanding the research scope, like we can extend this beyond 4 scenarios into more complex economic judgments like bargaining and public goods and competition or multi-agent markets. And second, integrating into traditional methods, like goal is not replace economic methods but to integrate. Yeah, thank you.
Okay.
Okay,
Thank
Ranjit.
you for your presentation. We
Okay,
can
madam.
take any question if
No, no, it's
any.
okay.
Okay. So I think there are no more paper presenters left. So with that, we conclude today's paper presentation session at UNI-TEAS. We sincerely thank all our presenters for their valuable contributions and our audience for their active participation. A special thanks to our session chairs for guiding the discussions with clarity and depth. Now, I would request all the participants present to kindly switch on their cameras as we take a virtual photograph to capture this memorable session. Please switch on your cameras, everybody. Wait a second. All right. Thank you all, and we look forward to seeing you in the next session. Have a great day ahead.
Thank you, ma'am.
Thank you.
Thank you.
Thank you. Thank you,
And
sir.
I have a question, ma'am. Excuse me, ma'am.
Yes.
Ma'am, what will be the further proceedings after this presentation?
I do not have knowledge about that.